Alright, so in this video, I'm going to be solving the equation x to the power of x to the power of 3 is equal to 729. So, to solve this, what I'm first going to do is take the power of 3 on both sides. So I get x to the power of x to the power of 3 to the power of 3 is equal to 729 to the power of 3. Now, if I have something in the form a to the power of m to the power of n, this is the same thing as a to the power of m times n. Now, m times n, I can also rewrite as n times m. And if something in the form a to the power of m to the power of n is equal to a to the power of m times n, then a to the power of n times m should also equal to a to the power of n to the power of n. So in simpler terms, a to the power of m to the power of n is equal to a to the power of n to the power of n. So now from here, I have x to the power of x to the power of 3 to the power of 3, and I can think of x to the power of 3 as m and 3 as n. So if I switch the places of these two, I get x to the power of 3 to the power of x to the power of 3. And remember, this is equal to 729 to the power of 3. Now, from here, I'm going to let x to the power of 3 equal to the variable y. So I get y to the power of y is equal to 729 to the power of 3. Now, I can simplify 729 to the power of 3. So 729 is the same thing as, 729, let's find some factors of this. So a factor of 729, let's try to divide this by 3. 729 divided by 3, we have 2 over here, so we get 6. We subtract 7 with 6, we get 1. We bring that to 2. 3 times 4 is 12. And now we bring that to 9. 3 times 3 is 9. So I get 729 is equal to 243 times 3. Now, 243, if I divide this by 3, I get 81. So I have this times 3 times 81, or sorry, I have 3 times 3 times 81, and 81 is the same thing as 3 to the power of 4. So I have 3 times 3 times 3 to the power of 4, which is equal to 3 to the power of 6, meaning 729 is the same thing as 3 to the power of 6. And 3 to the power of 6, I can break that down into 3 squared times 3 squared times 3 squared, which is equal to 9 to the power of 3. So I'm going to replace 9 to the power of 3 with 729. So I get y to the power of y is equal to 9 to the power of 3 to the power of 3. And the reason I did this is because 9 to the power of 3 to the power of 3 is the same thing as 9 to the power of 3 times 3. And 3 times 3 is 9. So I get y to the power of y is equal to 9 to the power of 9. And now I can use the property a to the power of a is equal to, if a to the power of a is equal to b to the power of b, this means that a equals b. So in this case, y is equal to 9. Now, recall how I let x to the power of 3 equal to y. Meaning, I get x to the power of 3 is equal to 9. So now to solve this, I'm going to take the cube root on both sides. So I get the cube root of x to the power of 3 is equal to the cube root of 9. Now the cube root of x to the power of 3 is simply just x. So I get x is equal to the cube root of 9. And this is the same thing as 9 to the power of 1/3.
Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. So we have x to the power of x to the power of 4 equals 64. Now, what I'm first going to do is I'm going to take the fourth power of both sides. So we're going to take the fourth power of x to the power of x to the power of 4 as well as 64. Now, an important property of exponents is that if we have a to the power of b to the power of c, this is actually equal to a to the power of b times c. So what we're going to do over here to x to the power of x to the power of 4 to the power of 4, we're going to multiply x to the power of 4 times 4. Because in this case, x to the power of 4, this is b, and 4 is c. So this would equal x to the power of x to the power of 4 times 4. And this is still equal to 64 to the power of 4. Now, what I'm going to do is I'm going to switch this so that it's in the form x to the power of 4 to the power of x to the power of 4. As you can see, all I did was switch the order. Before it was x to the power of x to the power of 4 to the power of 4, and I simply switched the order of 4 and x to the power of 4, and that is completely legal. And this is still equal to 64 to the power of 4. And notice how x to the power of 4 and x to the power of 4 are the same, right? Well, I actually want to convert this equation so that it's in the form a to the power of a equals b to the power of b. Because if it is in this form, then we could just set a equal to b. So we already have x to the power of 4 to the x to the power of 4, so we already have a to the power of a. Now we just need to convert 64 to the power of 4 so that it's in the form b to the power of b. So 64, this is equal to 8 squared, right? So we're going to replace 64 over here with 8 squared. So we're going to have 8 squared to the power of 4. And we're going to use the same property, a to the power of b to the power of c equals a to the power of b times c. So 8 to the power of 2 to the power of 4, this would equal 8 to the power of 2 times 4, which is 8. And we still have x to the power of 4 to the power of x to the power of 4. Now we can say that if a to the power of a equals b to the power of v, a equals b, right? So if x to the power of 4 to the x to the power of 4 equals a to the power of 8, then we know that x to the power of 4 equals 8. Now we want to cancel this fourth power here, so we're going to take the root of 4 on both sides. Now these two would cancel out, so on our left side we would have x, and our right side we would have equals positive or negative, remember it's plus or minus, the fourth root of 8. And this is our answer.